All right, so number 14, fast like a turtle. Here we go. So this is, we have to graph this now, and this is a cosine function. We know cosine starts high, goes down, and then comes up like this, right? Now, what is the period, normal period length for one complete cycle? Yeah, 2 pi. Okay, so we figure out the distance, or how long it's going to take to complete one full cycle by going 2 pi over whatever the b term is. Here the b term is 1, so we know that it's going to stay at 2 pi. Okay, so I go to 2 pi, and then I cut it into quarters because I'm finding my key points here, okay? So I know that it's going to start high, come down, go low, go back, to boom, okay? That's what I'm looking for. Now what's half of 2 pi? Pi. What's half of pi? Pi over 2. Now what should go right here? 3 pi over 2, okay? So if you were going to use a t-chart for this one, these would be the points that you would want to use. Okay, because that's when it's going to be at its x-axis, or x-intercept, excuse me. That's when we're going to have a maximum, and then minimums and stuff like that, okay? So from here, do you guys see this negative? That just means that I'm going to reflect this over the x-axis. So I know normal cosine looks something like this, where it starts high, comes down, and goes like this, okay? So all I'm going to do is just reflect it over the x-axis. So this point right here, I'm going to reflect it down here. X I can't reflect when it's on 0. But this one I could reflect it up. This one stays there. This one gets reflected down this way. So in the blue is what the graph would look like for number 14. Got that? Okay. Same thing kind of works for number 15. Sine, we know that sine completes one full function, one full cycle, usually in 2 pi. So we're going to go 2 pi over b to figure out how fast it's going to be going. So this is 1, so it is going to be completing it in 2 pi. Okay, so let's do this. 2 pi. What's half of 2 pi? Good. What's half of this? Good. What's this? You guys know I'm just picking, normally whenever your period is 2 pi, then you're just picking these key points, right? See, this is 3 pi over 2, this is pi over 2, this is pi, and this is 2 pi. Okay, you're just picking the coordinates there, or the axes. Okay, so here, sine normally goes like this. It goes up and down and then up, right? But now the 3 means that we have to increase the amplitude to 3. Okay, so like this, goes up, down, around. Okay, so all it did is just kind of stretch it vertically. Alright, next, number 16. As long as you know how to do this, then you could do this. Okay? Let's start off with the basics and see if we can figure out how to do this. How would I add these two fractions with two different denominators?
Common denominator.
Yeah, what is the LCD?
6.
Good, 6. Didn't you just multiply 2 times 3?
Yes.
You just took the two denominators and multiplied them together. So that means I need to multiply this side by 3 on the top and the bottom, and this side by 2 on the top and the bottom. We're going to be doing the same thing with this one. The LCD could just be the product of both of the denominators, but sometimes if you have like two factored things, I would just factor this and just see what it would look like. So x, what is that going to be? Minus 5 and then x plus 2. Okay, and the reason why I say this is because if I have denominators 5 and 25, is my LCD going to be the product of both of these? No, the LCD is going to be, you know, if I have a repeat, like see how there's a common factor, the 5s in both of them, then I don't have to necessarily do that for the LCD. So let's clean this up then. We're going to say I've got to multiply this whole denominator by this one. Okay, so I have the 2, or let's say the 1/2, and then I got to multiply the top and the bottom by x minus 5, x plus 2. Okay, then over on this side we have the 3, and then we have the x minus 5 and the x plus plus 2. And I have to multiply it by 2. Alright, so this, well, actually I'm going to go ahead and multiply it out, and I already know what it looks like. I already have it down. Okay, and then I have plus, and then 3 times 2 is 6, and then we're just going to say LCD on the bottom, okay? So what can I do for the top part here? Anything? Good, so negative 10 and positive 6, what do I get? Good, and then we have the LCD. Remember, the LCD is 2 times this denominator part. Now I'm curious, I don't think there's going to be any factors. So look, possibly you could factor the top and factor the bottom and see if anything divides out or something. But there are no factors of, yeah, see this one's, there's nothing going to, see this is just going to be 4 and 1, and that's a 2 and a 5. So that's not going to cancel out. So this would be the final answer here. Okay? Alright. Determine where the function is increasing. So increasing and decreasing is going to be the kind of like the time. Remember the time? Okay? So when was it increasing on this interval? So from negative 1 to positive 1. So increasing, I'd say it's open circle, so that's going to be like this, to positive 1. And why do I put a bracket here? Because it's closed. Good. And then it's also increasing again from 2 to 4, but parenthesis, okay? Now you could put a union symbol if you want, but you don't necessarily need to for increasing and decreasing. Okay, I'll put it there for you guys because I'm sure someone's worried about it. Now, decreasing from negative 1 all the way down to 2. Now they're both solid, so we'll say this is increasing, and then decreasing is going to be from 1 to 2. Okay, that's an easy money problem right there. Alright, next it says evaluate tangent of 30 degrees. 30 degrees is like this. So 30 degrees, this is the long side. So x is radical 3 over 2, and then the y is the short side, so that's 1/2. Tangent is sine over the cosine. So 1/2 over radical 3 over 2. Divide that out and then rationalize. So you have radical 3 over 3. No, 3. Because you have to multiply by the, whatever that is. Rationalize the denominator. Okay, so tangent is going to be radical 3 over 3. Now 3 pi over 4, since it has a 4, that means that it's one of the 45 degree angles. And then it's 3, so it's got to be over here, so that's going to be 135. So cosine of 135, that's the x value, so it's going to be negative radical 2 over 2. 7 pi over 6. 7 pi over 6 is, well, 6 pi over 6 is going to be right here. 7 pi over 6 is going to be one more. So what is that one that's right here? 210, right? So this is 210 that it's talking about. Sine is, so this is the x value, this is the y value. So it's going to be radical 3 over 2 and negative 1/2. So sine of this is going to be negative 1/2. Okay? Alright, a couple more, and then we'll move on. Alright, here it says to factor. Remember, whenever we're factoring a cube, it goes like this. If you have two things that are being cubed, you can factor it where there's a binomial and then there's a trinomial. Now whatever was cubed in the first term, that's what goes right here. Whatever's cubed in the second goes like this, and then you square the first, you square the last, and then you multiply them together in the middle. Okay? To figure out what the signs are, that's when you use SOAP. Okay? So if this is positive, it's going to be same, opposite, always positive. Okay? Now if this was a minus sign, then obviously those things are going to change. So what was cubed to get a cubed? Good. So that means I go like this, a squared. Okay, what was cubed to get 27? 3. What was cubed to get b cubed? B. Now we square it. What's 3b cubed squared? Good. So how about 9b squared? Okay, then you multiply them. So that's going to be 3ab. And now we do same, opposite, always positive. So same, opposite, always positive. So that's going to be the answer for that first one. Okay, and I don't think we can factor that last part there. Alright, let me grab this and move it down. Oh, come on. Okay, doing the next one. What was cubed to get 8? What was cubed to get a? Good. What was cubed to get 64? What was cubed to get good? Okay. Now this one's going to be 4a squared. That one's going to be 16b squared. Then you multiply them together, so that's going to be 8ab. Okay, now same, opposite, always positive. So same, opposite, always positive. Oh, positive. There you go.